Okay, so previously when we solved exponential equations, we had stuff like this, maybe 2 to the 2x plus 1 equals 2 to the 5x, something like that, right? And then we canceled out the bases and we just solved from there. However, the type of problems we're going to be looking at today does not have the common base where we can do this, okay? So if using a common base is not possible, like we would do here and cancel them out, then these type of exponential equations can be solved using logarithms, okay? So the first step is to isolate the exponential expression. So let's look at the first example. This is my expression right here. Here's your base with its exponent. We want to isolate this part. So what I'm going to do first is divide both sides by -2. Now my base along with its exponent is by itself. It's equal to 25. So that's your first step, is to get that part isolated, your exponential part isolated. Okay, let's go back to the steps. We did that part. Now we're going to take the logarithm of each side. So let's go ahead and do that. I'm going to take the log of each side. So log. It does not matter which base you want to use, as long as you use the same log on both sides. You can turn this into a log 7, log 9, log 9. You can do log base 10. You can do whichever one you want, okay, as long as they're the same. They need to match on both sides. Okay, so we took the log of both sides. Next step. Expand the logarithms if necessary using the power rule. So let's use the power rule. So the power rule says that exponents can come down to become the coefficient. So what we will have is 4 minus x log of 8 equaling log of 25. We just use the power property. Okay, next step is to solve. So we're going to solve. What I'm going to do is divide both sides by log of 8 and log of 8. So I will have up here 4 minus x equals, put this in your calculator. What is log of 25 divided by log of 8? And remember, your base needs to be the same. So you can type in 10 and 10 as long as they are the same. And let me know what you get. 1.5479. Perfect. Okay. Now I'm going to subtract 4. Can you subtract 4 from this? Let me know what you get. Thank you. And then just divide both sides by a -1. So we'll get x is equal to 2.452. 452,000. So we're going to round to the nearest thousandth place. That means 3 numbers behind the decimal. Okay, next example. We have this one. Okay, so notice our bases are not the same. Our bases are not the same here. So what I'm going to do, they're already isolated. I'm going to go ahead and use the power property. So I'm going to have 2x minus 1 log of 8. Sorry, guys. Make sure you take the log of both sides. So write a little log there. Write a little log. And then that exponent comes to the front. So we'll have equals x plus 3 times log of 5. So first, guys, we took the log of both sides. And then we did the power property. Okay, so here we are. Now, there's different ways you can solve this. I'm gonna do it maybe the easiest way. Guys, log of 8 and log of 5, those are just numbers. You can type that into your calculator and it will give you a number, okay? So think of these as numbers, they're constants. So I'm gonna divide this side by log of 8. And I'm gonna divide this side by log of 8. So what I have here is 2x minus 1 equals x plus 3 times, and I have this number here. Can you guys type this into your calculator and tell me what that is? More time. Okay, say it again, please.
0.773 976.
976. Okay, I'll just write all the numbers. Okay, let's round this real quick. I'm going to round this to the third number behind the decimal and make that a 4. Okay, thank you. All right, so guys, let's just go ahead and solve now. So we're going to distribute. This will be 0.774 thousandths x plus, let me know what that is, and then 2x minus 1. Say it again. 2.322. 22. Okay. All right. And now we just solve. So I'm going to add 1 to both sides. So I'll have 2x equals 0.774 thousandths x plus 3.322. And then subtract 0.774x, subtract 0.774x. What does this become? 1.226, thank you, equals 3.322. We're going to divide both sides by 1.226 thousandths. And what y'all get? 9962. Oh, okay. 70962. Okay, perfect. That's my answer. I'm going to have you guys round this 6. We'll make this go to a 10, right? Okay, so this will be 2.71. Because we round to the thousandths place. So we have to look at the number after the 9, which will round that to from being 0.9 to being a 10. Make sense? All right, nice. Okay, just one more example, guys. Say you have e to the 3x minus 4 equals 7. Whenever you have an e, you're going to do natural log of both sides. And the cool thing about natural log and exponential, those cancel out. So you're going to be left with 3x minus 4 equals the natural log of 7. And then from there, you can just solve. So this will give you a number in your calculator. Calculate what that number is. And then you'll add 4, of course. And then you'll divide by 3. So this would be your answer. You can simplify this down once you calculate what natural log of 7 is.